One method of describing a variable that has been gaining kind of influence in statistics is that of the box plot. The box plot takes the median and really it takes the quartiles, the first, second, and third quartile, along with a little extra information, and displays that all nice and clean on a visual. And so we're going to walk through calculating a box plot or drawing a box plot right now. And so I have some data pulled up here, and I think we've worked with this data in previous videos, but we just have 39 observations here, and I have them ordered. Just like when we calculate means, or sorry, not means, when we calculate medians and the percentiles, we need the data sorted here. And so we're focusing in here on this value variable. And I have it highlighted, must have been from a previous video. The median here being the 20th observation out of these 39, giving us a value of 30. So half of the values are smaller and half are greater. So we already know, so we have the second quartile. But we do need the first quartile. So the second quartile was 30. What's the first? Well, let's go ahead and use the method we've been working on. So n plus 1 times 25 over 100, where n is 39. And so we get 40 times 1/4. So our 10th observation, so the answer is not 10, but the 10th observation gives us a first quartile. So this is LP is equal to that. And so the first quartile is, I'll just write this down here again. The first quartile is going to be 11. Second is 30. And the third, which we will need, is, let's just go back to red here. The third is going to be L75 is 39 plus 1, so 40 times 75 over 100, which is going to be 30. So we look up the 30th observation, and we see that that is 45. Okay, so let me actually, just going to kind of highlight those. So we have our quartiles here. Again, we probably could have done that without the calculations because we have this nice round 39 plus 1 being 40. But we have 3 quartiles now. We need a little more information. What did I say it was? 45. Okay, so I'm going to actually start drawing our box plot. And the way we're going to do that is to, we basically put it on a set of axes, but we really only use the one axis. So I'm going to do it horizontally, but you will see these vertically as well. And so we'll do something like 5, 10, 15. This is going to get much too gross. I'm going to run out of space, I'm realizing now. 25, 30, 35, 40, 45, and we'll deal, well, I regret my decision. Okay, we're gonna go to a new sheet, and bear with me here. We're gonna build the box plot on this new sheet here, and we will do 10, 20. And so the box plot is comprised of a box and then also some whiskers, which we'll get to. But the box is built out of simply the still gonna kind of run out of space. Didn't plan very well. The box is built out of our 3 quartiles. So we have a value at 11. We're just going to build that with a vertical line. Okay, our second quartile is at 30. And our third one is at 45. We simply connect those to build the box. Okay, and so already we can see I'm just going to label these. You don't always see them labeled, but we have Q1, Q2, and Q3. And so visually, as a reader of this visualization, I can quickly pick up the first, second, and third quartile, and of course the second being that median. We also get a sense as to where the middle 50% of our data is. And in fact, here, this box contains the middle 50, right? So the Q1 is set where there's only 25% to the left of this, and there's only 25% to the right. And so we're left with 50% within the box. Okay. One thing we'll need as we move forward here is we're going to need what's called the interquartile range. So I'm going to jump back here. And in the interquartile range, the IQR is simply Q3 minus Q1. Right? It's the interquartile between the quartiles and the range of that, much like our range, for the whole data spans from 2 to 115, so it's 113. Here the range is just how far is there between the third and the second, or the third and the first quartile. So for us, that is 45 minus 11, or 34. So that's what's referred to as the interquartile range. I said we're going to build some whiskers. And the whiskers are going to extend 1.5 times the IQR, or that's kind of the default length of the whiskers, and we'll see that sometimes that varies. So 1.5 times 34 is 51. Okay, so I'm going to jump back, and we're going to build whiskers that go a length of 51. So we were at 45, so I need to go to, yeah, I definitely ran out of space. 45 plus 51, whoops. Going to take me to 96. Is that true? How's my math today? So that takes me to 96, which I guess I did not quite run out of space for that. And we finish that with a vertical line as well. And so here we have a whisker that extends 1.5 times the interquartile range. So it's 1.5 times the length of this box. And that extends all the way out. And then, but notice that that does not quite encapsulate all of our data. So we have one data point still here. And that's at 115. And so let me just, I'm gonna kind of fudge the numbers a little bit. We're gonna scrunch this up a little bit. And so what we do to indicate that is we're going to put a star or an asterisk at the value of, pretend this is out at 115. Okay, and that tells the reader that there is a data point that is quite far away from kind of the middle of our data, or where the rest of the data falls. And one way to reference that is that this is an outlier. And as we move through the course, we'll talk about specific ways to calculate whether or not something is or is not an outlier. But this is one method that people use, whether it's beyond 1.5 times the interquartile range from Q3. And so, yeah, there'll be other ways to quantify or to calculate whether something is an outlier, but this is one of those. And so this gives the reader an indication that there's maybe a data point that we want to think a little bit more about what's going on in that case. So we have one whisker down. We need to add in the other whisker. And this again would stretch 1.5 times the IQR, or 51. And so we were at 11, so this would go to negative 40. And so let's say that was about here. However, we're going to trim this whisker. Okay, so we don't actually want to put the whisker this far. Not because it's negative. It going negative is completely fine. We just don't happen to have data down there in this data set. And so we actually, so let me trim this up. We only extend the whisker to the lowest value in our data. So, for instance, in our case, that's 2. And so our whisker only stretches to the extent of our data. So it either goes 1.5 times the IQR or it hits the end of the data. And there we have it. We have a functioning box plot. Excel calls them box and whisker plots, so I might occasionally switch into that language. But here we have it, and so we can look at it and we quickly see. All right, I know where the median is. I know the extent of the quartiles, and I can even see that there's an outlier. I know the minimum is, maybe I can't see exactly, but I know it's less than 10. It's on the low end of 10, and I have values up near 100. So good snapshot of the data. And I mentioned it's growing in popularity, and one of the reasons for that is I think people have grabbed on to the idea of being able to compare across different groups of data as well, and that's something we're turning to in Chapter 4 is thinking about having multiple variables going on at once. And I'm going to just pull up a picture here. And this is from a different textbook, and we're not covering it here, but I want you to show, or I want to just show you some of the added benefit of a box plot. And what we have is so instead of just one box plot, first of all, they're turned vertically, which again I mentioned is fine. But we have 5 different groups here. So we have 5 different box plots, and I think in this case it's sales prices, home sale prices. And so we can get a snapshot of each of these different areas, these different communities, and you can see, okay, in Fairview, it looks like the median is right at about 200,000, and we can see the ranges and the whiskers. We can compare that visually quite quickly and say, okay, in Shadyside, it's much higher. We can compare Groton and Irving, which might have very similar medians, but we can see how much clumped together the Groton is. We can also see there's an outlier, as opposed to Irving, which stretches and is very spread out. So again, a pretty easy way to visualize the difference between different data sets or different variables or sub classes as well. And so that I think is one of the driving forces as to why people tend to lean on box plots more so than they used to. Yeah, and we can let me grab this, and in Excel it's quite easy to put in a box plot. Now this is if you have a more recent version of Excel, and one of the ways you can kind of tell what's growing in popularity is back, I think it's even if you have Excel 2013, it's much more cumbersome to input a box plot, but nowadays it's a few clicks. So I'm just going to grab my data, go up to, you can't see this, but I'm inserting it would be more helpful if I showed you probably. So I'm just going to go in and there's a it's up here somewhere. We'll find it. There's a quick little, I think that, again, they call it, we'll go up, we're in insert. I've got some other calculations here, but it's in the little, down here, right by a form of histogram here, but the box and whisker. And Excel actually puts a pretty nice kind of default look to it. And again, now we're vertical, but this looks, it looks a little nicer than the one I drew, but it has the same information. We can see those medians at 11 and 45, and the median at 30, and then the first and third quartiles at 11 and 45. We can see that outlier. And this is kind of hard to see, but Excel adds in one other little feature which I kind of like. That's not standard to box plots necessarily, but there's a little faint X on there, if you can see, and that's for the mean. And in fact, I have the mean and the median calculated up here, and yeah, so the mean is about 32. A nice little feature, and yeah, these are pretty malleable as well, so you can do a lot of kind of snazzing up, and it's not that hard to actually start adding more series in here as well and seeing them side by side. But yeah, so that's kind of a brief overview of box plots. All right,